Control chart. Control chart is also called statistical control process, or it is also called statistical process control. And when we call it as a statistical process control, it is abbreviated as SPC. Okay. Now I have created a table here with 20 different data points, and against each of the data points we have data values. What does this mean actually? This means essentially we are taking care of a particular process or a particular process step or a project testing point, and for that project testing point or a particular process step or a particular process, we are trying to create different data points and data values to test and audit whether the process or the project step is going as per our expectation or the requirement or not, right? What does this mean? That there are certain control limits which is already identified or which is already decided during the very start of the project, and that decision is taken in accordance or in consideration with the customer or the client for which the project is getting created, correct? Now when we are trying to audit a particular process step or a particular project testing point, then we need to understand that whatever values we are getting, it should not cross that control limit, and that is why it is called upper and lower control limits, right? Though we are not able to understand here exactly what is the upper and lower control limits, but we'll find it out using our definitions of USL, LSL, LCL and UCL. We'll study in later some point of time. Now let's just focus and concentrate on this particular table. So as I mentioned, this is a particular process or a project step, and we have taken different 20 data points, and these are the values. Like for example, the first data point gives us the value of 61, the second data point gives us the value of 65, so on and so forth until 20 different data points or 20 different data testing points. And if you sum to total of the entire values, will give you 1263, 1263. That is the sum total of 61 plus 65 plus 67 until 58 plus 64 plus 66. And when you try to take the average of it, the average is also called as mean, and it is the sum of all data points divided by count of data points. The sum of all data points here is 1263 and count of data points here is 20. So 1263 divided by 20 gives you 63.15, which is your average or mean. Standard deviation, I have taken help of Excel, and the formula which is used here is stdev.s, and that will give you the standard deviation of 4.37. That's 4.37 against all these 20 different data values. So standard deviation basically gives you an idea that in what range the values are getting deviated in the upper side as well as in the lower side, right? Now let us revisit the definition of control chart. A control chart is a graphical representation which is used to study how a process is changing over time, or how your process step is changing over time and is behaving. And if it is behaving, it is giving you a variation of the data values both at the higher side and at the lower side. And let us plot those data points or data values in the time order. That will help us give you detect the trend or the shift in the process, or that will also give you an idea about how bigger that variation is from the mean both at the lower side and at the higher side by comparing them to the statistically calculated control limits. Now the question essentially which comes here is, what is statistically calculated control limits? So it is USL and LSL, which is upper specification limit and lower specification limit, and nothing above this or below this will be acceptable by the customer. That means while we started this particular project and we started working on the process, these USL and LSL are defined, agreed, and as per the agreement and as per the contract by the customer or a client. What is LCL and UCL? That is internally managed and defined by the project team. It is internal to the project, whereas LCL stands for lower control limit and UCL stands for upper control limit. Okay, so we'll try to understand exactly how these LCL and UCL is getting calculated. And if you see the formula of UCL, which is upper control limit, it says it is equal to average plus 3 into standard deviation, which means 63.15 plus 3 into 4.37 will give you 76.25, which is your upper control limit. And LCL is lower control limit, which is average minus 3 into standard deviation, which is equal to 63.15 minus 3 into 4.37, and that will give you a value of 50.05. Now mean, now how this mean, UCL, LCL and the other control limits looks when you try to put it into a plot. So this is how it will look like when you will try to put it into a graph or a chart, and the top left hand side you will see the statistical control chart, right? And there are three different there is one horizontal line green which is mean, and mean is calculated as 63.15. There is on the top between 75 and 80 you will see an amber color horizontal line which is your UCL, upper control limit, internal to the project team, which is 76.25, and we have seen how we have calculated that, right? And at the lower bottom side you will see at 50.05 there is a red horizontal line which is lower control limit, again it is internal to the project team, and if any value, if any data value varies or ranges between your less than 76.25 and greater than 50.05, it is still in control and the project or the process is still in the control. But if the value is greater than UCL or lesser than LCL, then it goes out of control, right? So again, that UCL and LCL is the line wherein the project team starts taking action if any data value goes beyond UCL or LCL, right? So this is the learning concept of rule of 7 and outliers. Now here you will see that UCL and between UCL and USL, which is your upper control limit and upper specification limit. To refresh the memory, upper control limit is internal to the project and upper specification limit is as agreed by the customer. So the project team understands that they will try to maintain the process data value between mean and upper control limit, which is 63.15 and 76.25. The moment it will go beyond UCL, and then it becomes a question, and the project team will start working on it to identify what are the gaps, how to fix it. They will do a process analysis, they will do the process deep dive, process re-engineering, process auditing, and finally the process will be fixed to bring the data value if anything comes below 76.25, which is upper control limit. And same goes for LCL and LSL. There is a buffer between LCL and LSL. Now USL and LSL, which is a specification limit, is given by the customer. There is no we do not define upper specification limit and lower specification limit, right? Now let's look at the rule of 7 and outlier. That's the concept of rule of 7 and outlier. Now let us look at the concept of rule of 7 and outlier. If any 7 data points are consecutive, 7 data points are nearer to each other. Try to mark the definition. The 7 data points are consecutive and coming very nearer to each other, then it is rule of 7, and it is again a question to the process why all the data points are segregated around one corner, around one data point only, right? And it is needed to be fixed and looked into. Same goes for outlier. Outlier is something which is beyond our control and which is beyond even expectation of the client or the customer. That is, it has surpassed the upper specification limit or the lower specification limit. Hence, I have kept it as a red dot outlier, and that is a big question because your project can go out of your hand and customer can put a penalty on top of it. So it is better that whatever we are doing as a project manager, your data values should be under control, which is upper control limit and a lower control limit. Let's recap the major points. Statistical control, if the points lie between the UCL and LCL, it is under statistical control and that is maintained and managed by the project team. If the point lies outside the LCL and UCL, it is because of random causes, needs to be controlled and investigated so that these kind of situations do not occur in the future. Customer fixes the LSL and USL, it is per the contract, and there are no hands of the project team. It is all defined as per the contract with the customer. Anything beyond this value, LSL and USL, is non-acceptable. Out of control scenarios are 2, rule of 7 and outlier. Rule of 7 states that there should not be 7 consecutive points lying on one side outside of mean, and outlier is any point should not lie outside the USL and LSL. That is all about the control chart. Thank you.